I want to talk today about automating for an AI-led future and how automation is absolutely vital in digital twins. This is a pipe in our utility network underground in London. We have a massive problem there where restaurants, houses are putting fat down the plug hole, and this is causing something called a fatberg in our pipes underground. So if we want to create a real digital twin of this underground pipe, we actually need to have the base data, the pipe where it is, but also we need some sensor data as well, in order that we can have this accurate digital twin. And it ties nicely into this section with AEC, because if we want to do planning around new houses, new buildings, and this is so important, how can we do it when we don't really know what's happening underground? So there is a significant problem to be solved, and some of these stats have already been mentioned today. It's about creating climate-resilient infrastructure. So we've also got retrofitting to happen as well. And there's a lot of money that needs to be invested during this period. Successful digital twins really rely on automation, bringing together that data so we can make accurate and timely decisions. So we are global leaders in geospatial data management, and we absolutely love difficult geospatial challenges, particularly when you're bringing lots of different data sources together. We work across a broad range of industries, generally mission-critical industries. We are a small part of a very big ecosystem, and we work with partners closely. So here is a picture of that geospatial ecosystem, and you can see where we fit into this. So at the bottom, I've just listed lots of data types, and we don't care at One Spatial. We're data agnostic, system agnostic. We do spatial data, location data, whatever data, but we do focus generally on location and geospatial data. We bring in the data through our One Data Gateway portal, and then we get going on the data with our rules engine, validating it, cleaning it, synchronizing it, updating it, and providing some analysis on it. And then once you've got your data clean, you can put that into your applications. In France, we've got some applications on top of the Esri platform. We've got some of our own applications we've been building using this core data function. And then obviously we have our customers' applications in the gray top box, including the NUR. But all of these business applications are really powered by data. At Google, they've got loads of campuses in the US, and they want a complete digital twin of all their campuses. And that's for working out where their employees are going to sit, down to making sure the plumbing and the electrics are all okay. And the key thing here is about bringing data in from their supply chain. So they want all their suppliers to produce the CAD drawings, and we check all those CAD drawings before they put it into our system using that One Data Gateway and One Integrate. But let's have a look at it from a different perspective, a national scale digital twin. They probably don't want all of that data at all. Maybe they might want the solar panels. Maybe they might want the floors. Maybe they want the doors. But, so it's deciding at this point, what are you going to do? Are you going to decide to create that national scale digital twin, and you're going to incorporate all the solar panels onto that data set and then release that data set? Or are you going to create a linkage between maybe this Google BIM data and your national scale digital twin? So there are different ways that you can do it. The National Geographic Database, they actually released a new update of this in October, and this actually now has floors incorporated into it. And the key use case for this is actually around emergency services, but they've gone that route to actually just give that extra bit of data about the building. But in the UK, we're creating this unified, accurate map of all the underground assets to present utility strikes and enable smarter planning for infrastructure. And there's a huge benefit to the economy as a result of this. On the left, you can see the real world, and on the right, you can see the digital map there. What we're doing in this case is you've got all the data coming in from the different asset owners. So there's 650 different asset owners that are contributing to this data set. And so we're bringing that into our platform through the One Data Gateway. Then we clean all the data, get it sorted, and the rules that are here are being defined by the Geospatial Commission, and we're actually using the standard from the mudding model to help with this. And then it goes into Ordnance Survey, and now running the application to where you can view the National Underground Asset Register data. This is voluntary collaboration at the moment. So the 650 asset owners that submit the data will then be able to use the data, but it is actually going through Parliament now, so at some point in the next sort of 18 months, it will become mandatory that all these asset owners have to provide the data. In terms of real-time updates, we talk a lot about digital twins needed to be in real time. For the purposes of the National Underground Asset Register at the moment, we're doing some weekly, some monthly, and it's probably sufficient for current needs, but let's think about the future. I mean, NUAR probably wants to be using a lot of systems. I know I want to use it in the one Streetworks, which we're going to look at in a moment. But if you start bringing in things like sensor data, back to my picture at the beginning, you're really going to need those updates more quickly, so something that needs to be given thought to. What's One Streetworks then? So I was really excited. We've been creating One Streetworks for the last 3 years. And what it is, if you want to dig up the road, you have to apply to the local authority in the UK, and you have to send them a plan of your cones and your traffic lights. And there is a rule book that says how this all has to be set out. And what we've done at One Spatial is we've taken data, put it with the rule book, and we can create these plans in literally 2 minutes. So we really are solving a problem here, and we're solving it through data and automation. And the key data source that we're using on this is the authoritative data source from Ordnance Survey that you can see in the yellow box at the bottom there. But we're bringing more and more and more data, getting this platform more and more rich, and that means that we can do actually more with this platform than we originally thought. When we started on this project, and particularly working with Surrey County Council in the UK that we've landed a big project with, we're now actually creating a real-time digital twin of the roadworks. And the reason why Surrey County Council is really wanting to do this is back to the problem I said around where I live. We are absolutely gridlocked with roadworks. So we're minimising the road closures. We've actually reduced road closures in Kent by about 40%. But by now having this digital twin where all these roadworks are happening in a particular area, it really gets, collaboration of all these different utility companies now. They're having to speak to each other and they coordinate. They couldn't do this before. This is all in the cloud. They jump on a Teams call and they can see where everything is happening in real time. So with our system, we are automating now currently 85%, and we're looking to get that to nearer 90 in the fairly short term. And I just then wanted to just touch on for my final slide really is around AI tools. So we can use AI at all aspects of the ecosystem. We can talk about, Earth observation data to, extract features to create some of this data. In our platform, we're bringing in more AI to do schema mapping through AI, and also, AI enable the rules. Use a ChatGPT to create the rules. And also, we can talk about, we've talked a bit about over the past few days around sort of these AI agents. These AI agents can go in. So, for example, with NUAR at the moment, you go in and you visualize the data. So you might want to say, I'm outside Harrods in Oxford Street, and I want to know if I dig up a hole out here, am I going to hit the gas pipe? Now, at the moment, you might go into the NUAR system, have a look, there it is. But maybe in the future, you can just ask the NUAR system that question. But I think we all know that that still means that the data in NUAR has got to be accurate. Whether I'm visually looking at it or whether you're using your AI agent, you still need good data there. So that's also another key theme I wanted to bring out. So I think really that's it for me, and I just wanted to go back to that sort of point at the beginning. It's all powered by data and automation, and I think we can solve some of these problems using digital twins, and that's it for me.